Welcome to Pratidwani, where we try to humanize science. I'm your host, GV Pawan Kumar. It is my delight, pleasure, and absolute, honor to welcome the guest on this episode, Urbasi Sinha. Urbasi is a trailblazer in quantum mechanics, experimental quantum mechanics, more so from a quantum optics, quantum computational, and a quantum information viewpoint. She and her lab has been actually was one of the best labs, not just out of India, but also across the world, which is exploring very interesting questions related to various aspects of quantum technologies and fundamental quantum optics. Urbasi is a professor at Raman Research Institute, but she was also is also an affiliate faculty at Institute of Quantum Computing at Waterloo in Canada, and also holds a appointment as an affiliate faculty at Center for Quantum Information and Quantum Computing, Toronto, Canada. She's very well decorated. One of the big awards which she has got recently is, of course, the Bhatnagar Award, and there are also many awards which she has obtained. But what is important is that Urbasi is an excellent communicator of science, and she's also been very active in also telling why quantum research is important and interesting. So, with this brief introduction, I welcome Urbasi.
Thanks a lot, Pawan, for this brief and embarrassing introduction. I didn't expect anything less from you.
So, Urbasi, as we do on the
it's Urbashi, actually. Just for your knowledge.
Yeah,
it's Urbashi.
Urbashi. Okay, so
it's like SHI, but there's no H.
Urbasi.
Oh. Doesn't matter.
Okay.
One is easier. Yes.
Yeah. Okay. The interesting aspect is to also know your origins. Please let us know what was the particular seed in your formative education which really got you interested in science.
Yeah, so I think, my story is pretty similar to many others, I would say, who have become scientists. I used to be one of those, people who people don't like in school, right? Like those who always used to want to get 100 in everything kind of person. So not a very likable person in that sense. So a typical, person who used to love science and maths from the age I know, maths from the beginning and science when it was introduced. So it was, I was a very studious student. And so it was kind of natural that, and I also had a flair for writing. So in some sense, it's not just, science and maths, but I also was good in languages and so on. But then as I grew up, it became obvious to me that what I really got interested in is finding out more about how things work. And so they are trying to get a little bit deeper into the question of things working than what is probably covered in a textbook kind of thing. So that is, so one, I mean, just to give you a little anecdotal example. So in school, I think I was in class 7 or something, and they gave us a homework. We used to have a lot of homework when we were growing up, right? And so they said that you have to use some kind of a paper and get some kind of a translucent light experiment done. Okay. And so, of course, we all went back with that. And my friend would tell you that she recollects that next day only one person came back having done something about the homework because it was not compulsory. So I had taken a cellophane paper, which was a wrap for some gift I had received, and tried to shine light through it and make the observations and all. So this is sort of the person I have been, throughout. And so it's not very unnatural to me that I'm a scientist right now. It is no like one great incident which changed my outlook forever. I don't have such a fascinating story. It's just a most natural thing for me to do. And both my parents are not scientists, so it has nothing to do with the great family influence in science either. It's just a natural instinct to know more about things, and also a little bit of an inclination to know more than what is already being taught. And so that is how I grew up. And so when I came to class 11, as it was called then, whatever it's called now. And so science was the natural choice for me to take as the stream and so on. So when I went to graduation, yeah, that is probably an interesting thing, which is a little different from, say, others, that, some of us have to do an engineering or a medical exam, like, so this joint entrance type things. And so because, of some family sort of aspirations, but mine didn't have that. So they said that you should do what you want to do. And I never wanted to become an engineer. Doctor would never go with me because I don't like, little mice who are not alive. And so dissection was a big problem for me in high school. And so my teachers were really worried that I wouldn't, they had aspirations that I would do well for the school and that kind of thing. And so if I went to dissect something, if that didn't work out, then my marks would go down. And so the school was rooting for my dissection, and it worked like a charm. And then later on, the teacher came and said, I think you had an anemic rat today. And so,
Okay.
I wouldn't become a medical doctor was obvious because I just don't I'm not comfortable with, death and it's an emotional thing. So I wouldn't be able to tolerate somebody not being well or, beyond a point. So naturally, it was basic science.
Nice.
So I'll stop if you have questions because you know me for a long time. I can go on for an hour, but I think you should interject.
No. In fact, see, these are very important elements. I would want to actually, get into some specifics. For example, in your formative years, including your school education, was there anything specific which really intrigued you to get into science? Because there will be some other direct or indirect impression during the school education. Was there anything you remember that you felt was very important in terms of how it influenced your thinking?
Yeah, so I think I would say that I have been very lucky that I have had some very good teachers also in school. And so I have not been in one school. I have been to 7 different schools actually as I have grown up. And so I've had different teachers in different schools that I have been to. And the science education was generally very good for what I have received. And also maths. Actually, maths is something I like equally.
Yeah.
And so I think we had very good teaching. And also, I always liked the practical aspects of the subject. So when we got into the lab work part, which was in grade 9 onwards, right? And so those I used to really enjoy. So I would say that, hands-on things is something I've always had let's say, a little more liking for than purely theoretical avenues. And so I think, these are things which sort of were the seeds which I'm sure were ingrained knowingly or unknowingly. And
so where did you grow up? In which particular place?
No particular, of course, some particular place. I was born in London, in England. But then, of course, I did not, we came back to India when I was 2.5. So I didn't have any education per se in London. So then we were in Bombay, in Mumbai now. And so I was in play school and then followed by, what is it, Arya Vidya Mandir, which is, a proper school. And so then we went to a place called Shiudi, which is in West Bengal, which is very close to Shantiniketan, which is more popular. So it's, associated with Rabindranath Tagore and so on, right? Yeah. And so Shiudi, I spent a couple of years, I was in school there. And then we went to Kolkata for a couple of years. And so I was in grade 2 and 3 in Kolkata. Then we went to Bangalore for 2 years, so grade 4 and 5. Then we went to Delhi for 5 years, grade 6 to 10. And then we again came back to Kolkata, grade 11 and 12, and then my BSc Physics honors also in Kolkata. Yeah.
Okay. It's a kind of Bharat Darshan within the.
So I learned Kannada as a third language.
Wow.
And Sanskrit as a third language. So I think some people would say there are the pros and cons, right? Like I actually like the pros because I think I have friends from more schools than most people would.
Yeah.
Which is enjoyable.
That's wonderful. Actually, this probably would also have influenced you to have a slightly more, international outlook going forward. Of course, because given that you have already sampled a lot of cultures, may have also influenced you. Very fascinating.
Definitely. And also, I went from ICSC to CBSC, in the board thing. And so that also was interesting because I actually, so things are taught differently. And so I actually have a sense for all of this. No thanks to me. It's my father had a transferable job, so we went with him.
Wonderful.
But yeah.
You had a sibling?
No, I don't have a sibling. Yeah.
Nice, nice. So, Urvashi, one more specific thing. Sorry if I am actually,
No, no, not a problem.
pronouncing your name. You should pardon my South Indian accent. So,
Yes, I'm in Bangalore, Pawan.
I
Yes.
yeah, it's a one of the things I'm very interested in is the fact that you also have a very good understanding of the mathematical aspects of your work. In fact, that is
Mhm.
something which is evident also in some of your papers and also in your talks whenever I've heard you. That will also be kind of connected to your formative education, because
Right,
if you want to really become a good experimental physics, and we keep telling that to our students, that
mm,
you have to be acquainted with mathematics.
absolutely. Yeah, I
And
cannot agree more. In
yeah,
fact, Pawan, mathematics, I mean, that's as I said, it's I have always liked maths as much as I have liked science. And in my mind, actually, I mean, and it's not just in my mind, it's of course the truth that mathematics is the language of physics. So you cannot really, I mean, it's a misconception that people who are not in science may have, that, when you're working in the lab, you're just fiddling with some knobs or something. That's not true. There is a lot of maths which goes into the physics that we are pursuing in our labs and so on. And so maths is something I would say it was my favorite subject till, of course, because science is not introduced in grade one, right? Like maths you study
yeah,
from
you're
the
right.
beginning. And so
Absolutely right.
so I do firmly believe that liking maths and being comfortable with maths, and for me, it was more than just liking maths. I used to solve, I don't want to, it's a conversation, but then, I used to do these grade 9 problems in grade 6. I
Yeah,
told you that let's
yeah,
not get into those details. So that is not the most thing I like most about myself. But then I used to like doing algebra problems and trying to see where I get stuck kind of thing. And I think those are very important now. Even when we
absolutely.
do these back of the envelope calculations that, whether something is going to work or not, sometimes I find that I can do things a little more quickly than even little, kids who are 20 something years old, because I like
Absolutely correct.
mental math. So,
Very nice.
yeah.
Fantastic. So one of the things I would want to actually also just touch upon, and then we move
Yeah.
forward in the timeline,
Yeah.
is the exposure to experiments. Were you
Right.
also kind of trained in some laboratory experiments during your school days? Because
Yeah.
I'm trying to get into the fact that
Yeah, I was actually. That's in
hmm,
fact very true. That's what I said, right? Like,
hmm,
so, of course, not in the younger classes. I don't recall
hmm,
we had a lot of practical stuff. But I would say from grade 9 onwards, that was when I was in Delhi. We actually had, lab
hmm,
work, as it was
hmm,
called, which, people used to take with different levels of seriousness.
hmm,
And of course, I actually used to like it a lot. And then, of course, in 11 and 12, I was in Kolkata. We had these, basic optics experiment, with
hmm,
lenses and,
hmm, hmm.
those sort of things. And then, as I said, biology, very sophisticated dissection experiments, which I liked in principle, but
Hmm.
not in practice. But it is just that the hands-on things have always, and chemistry, beautiful experiments we
Hmm.
did
Hmm.
in grade 11 and 12, with different kinds of chemical
Hmm.
reactions and all those things, coming up with a white material as opposed to a colored material. What does it mean? And I loved chemistry. So it's not, so what I'm trying to get to, of course, is that, while of course I am a physicist by training and currently, my vocation is physics, but I actually equally like chemistry and biology and maths.
Hmm. Hmm.
And I have actually studied all of them till grade 12. And even in undergrad, we had this. I don't know whether you did that when you
Yes,
had.
yes, same here. Yeah, you and I
Yeah,
too actually had it. Most of the, because I also I had an education which also included languages. That's how
right.
I'm also interested in humanities. That's one
Okay.
of the reasons,
Hmm.
because you do have exposure to that. Uh, One of the other aspect is that since you have sampled other languages too,
Hmm.
meaning you have lived in other places across India,
Yeah.
was that also an important thing when you were growing up? Did you also find that useful? Was there anything which you found that which was beneficial going forward in your career?
Yeah, I think I found it very useful because, as you know, as we go forward in the timeline, I have never been a very stationary individual. So I have
Mm,
been to many different places and done many different things. And uh, being able to adapt. So, I mean, of course, we are all Indians, but then we
mm,
have our own idiosyncrasies which are regional.
yeah,
And
yeah.
so, if you do not know my surname and if you don't interact with me for long enough, it's not so obvious that I'm definitely from Bengal.
Yes, yes, you're right.
And that is something which is because I have a little bit of everything. I mean, I like soaked vada for my breakfast much more than luchi aloo dum, right? Like so. So what I'm saying is that it is an enrichment, which is of course something you don't do yourself when you're a child, but then being exposed to all these different cultures within India
Yeah,
is itself has been very beneficial for me to realize that people can be behaving differently for the same situation.
situation. Yeah,
Yeah,
absolutely.
even if we are all in India, we're not necessarily all similar in our outlook to small, everyday things in life. And so when I now then, it helped me a lot when I have gone abroad and stayed in many different places, right?
Yeah.
Uh, yeah.
But I should mention that, the B in your first name actually is
Yes,
a giveaway,
I
because
know.
that is
That's
one place where you would
absolutely.
be
You
able
have
to,
the V.
yeah,
But
we
then that's why I
exactly.
said when you interact with me, I didn't say when you read my name. I mean, it's a giveaway. But
Yeah.
Sinha is not a giveaway.
Yeah, yeah, you're absolutely right. In fact, that is,
Yeah.
it's not an easy thing to guess that you have a connection
It's
with.
the O positive of the surnames. It could be anywhere. You could find a Sinha somewhere, right? Like it's very generic.
Nice,
And what
nice.
is your surname? It's Kumar?
Oh, no, no, because I'm actually a Pakka South Indian from Bangalore. So there is no surname, concept
No
of
surname.
surname. But I
Right.
have my Gopalapura Venkatramu Pawan Kumar. That is my full name, actually.
GV Pavan Kumar. Okay, okay.
Jeerpurgar, yeah, yeah. That's how it actually comes. Because I have our pin codes in our
Okay.
names.
I know. Yeah, we don't have that at all. Yeah.
Yeah, yeah. Okay, so going forward, please tell us a little bit about your college education. Once you actually graduated out of high school, where did you
Yeah.
go, and what was your trajectory?
Yeah, so I actually enrolled for physics honors. It's called physics honors degree in Jadavpur University in Kolkata. And so, I mean, as I said, I did not really give any joint entrance exams knowingly because I knew that I wanted to do something in fundamental
Hmm, hmm.
physics. Yeah, somehow that was in, nothing against engineers or I mean doctors I couldn't become, as I said.
Yeah.
That may have been a choice, but it's not my personality. So yeah, so then I enrolled there, and so that's 3 year degree. And
Hmm,
so it gives you and then so the first year couple of I mean you actually have the major thing is physics, but
hmm,
then you also have minor subjects which are chemistry and math. And then but then you're taught everything in physics in a certain way, and then after that I went to do my natural sciences tripos. So
hmm,
essentially after BSc physics honors you can do an MSc degree, and so that is something I did in University of Cambridge in UK.
hmm, hmm,
And so natural sciences tripos is a 4 year degree. Okay, but then because I already had the physics honors, I could enroll directly in the third year of the program and do 2 years of what is called part two and part three.
part three.
And then I
Hmm,
got what is called MSCI.
hmm.
For strange reason, they call it MSCI and not MSc. They also have the I. Okay, so that is what I did, and it was so these have all been very beautiful courses in their own right. And so after MSc, I enrolled for PhD again in Cambridge.
Yeah, we'll
And
come to that part of
yeah,
it, because I just wanted to get your transition also kind of
yeah,
captured
yeah,
from India to UK. In
yeah.
this particular case, Cambridge, and it's not an easy transition for anybody to make, right? Because the
Mm.
tripos is not a very straightforward thing.
No,
It's very
yeah,
difficult to also get into that program.
yeah.
Yeah, two things I want to ask. One is the encouragement what you got from your family, because
Mm.
that's very important. I assume that would have played a role.
Absolutely.
And second point is what was your thought process during the transition? How did you think about it? What made you take the decision, etc.?
So yeah, so that's a bit of a personal and
Mm,
professional decision, right? So what happened is, you may also know that I'm
mm.
married and I have a husband who's at IISc,
Yeah.
who is also from Jadavpur University.
I
And
should mention Anindra Sinha is actually an outstanding physicist. We'll very soon also have him on Pratidwani at some point of
exactly, yeah.
time.
So Anindo, of course, was a year senior to me in Jadavpur, and so we sort of, so that's the family aspect of the problem. But then, so he went to Cambridge in 1999 for his tripos, and so of course, by then we had kind of decided that we would tolerate each other till one of us is not alive. And so that is how we, so one of the reasons why I chose Cambridge was also a little bit motivated by the fact that Anindo was already there.
Okay.
And so that was one reason. But then the other reason is that my father actually was educated in University of Oxford.
Wow.
And so
Okay.
and London School of Economics. So
could you please name him, because it's important?
my
Because
father's not alive anymore. It's late Mr. Arun Ray.
Arun Ray. Yeah.
Arun Ray, yes.
Yeah.
So he was a banker, right? So he was in
Nice.
London School of Economics in Oxford, and he did his, he wasn't a scientist, but he was of course a very exceptional student as well. And so that was of course a long time ago. But then there was a thing that growing up that I would do higher education in England, and I was also somehow also coincidentally born there. Which didn't have anything to do with this thought, but it so happens that there was a connect. And so I would go for higher education in England was something that I kind of grew up a little bit with, because that's how my father did, and so on and so forth. But then when it came to the exact place and stuff, Anindo played a role there, because he already went. And so the idea was that it would be good if I also, went to the same place, and that same place happens to be one of the best places. So there was no particular reason to also have any academic misgivings about it. So Cambridge, and it, as you said, now it was about getting in, because it's not easy.
Absolutely.
But then that is where I would say that, my family has been the pillar of support throughout my life. I mean, as a kid, I didn't really realize it. I was an only child, so obviously very pampered, with no competition.
Yeah.
Right. And so, but then growing forward, it was a difficult decision, because I was an only child. So going away for that distance was a challenge when it finally came to it, right? Like, it was always there in the mind that this would happen, but when it did, it was not particularly easy. But then they have been stellar, and my mom did go to visit me in December itself. I landed up in October. She came in December. So I knew in 2 months she would come. So I was like that, right? So it is a good thing if, that can be done, especially as an only child. But then, of course, as you rightly say, it was a very competitive process. Also, so it was not just about the program, but also the scholarship. Because, I don't come from a very rich family. And so to be able to afford the whole thing on personal, this thing was not going to happen. And so I actually got this, Nehru Chevening scholarship. So Anindo got it the previous year, actually. And so, but then they only give it to one person. So I was the only one who got it in physics the year I did. I'm glad that we are not in the same batch. Then we wouldn't.
That's true.
Yeah. So we would. We are rightfully, we are rightly displaced, so that we don't really compete, and we have never done that, of course, because inadvertently also you don't want to do something like that with each other. But then, so I ended up getting it that year, and it required. Of course, I have been a good student, so that has come through. But then, of course, I also had project work and stuff that I had done in my undergrad, which all played a role in making this happen. And so that is how I landed up in Cambridge. It's a part personal, part academic decision.
Nice. One of the interesting aspect, if one looks into your career trajectory, is that your formative years also had a very strong component of condensed matter physics. In fact, that is something which I am really intrigued, because, of course, one can always look at it from the outside and tell, okay, she's a physicist. But within the physics, there are edifices: condensed matter physics, atomic, molecular, optical physics, etc. You started off in a very, intense program related to high TC superconductors, cryogenics, etc. And also you did some very interesting work in soft matter physics, which I am also very interested
about. Of course you are.
And then you moved to atomic, molecular, optical physics, more so the quantum aspect of that particular problem. This is not a usual thing. And it would require not only the depth of the physics, but also the breadth, because these transitions are not for some people it is only a one thing, but in your case you have successfully managed to also work on these areas. Give us a gist of first, how did you enter into the condensed matter regime and then into the AMOP?
Yeah. No, actually, that's a very, so you have done your homework. So thanks, Pawan.
Well,
So, yeah,
I have to
yeah.
do that. Yeah.
No, surely. So yeah, so when I was in Jadavpur University, it was, I mean, I didn't have any particular inclination towards one or the other. So it
Hmm.
was a bachelor's degree, so we were exposed to everything. And I must say, again, experiments were something I really enjoyed. So we used to do things as partners, so we had lab
Hmm.
partners. So and I would be the person who would actually do the experiment. There were people who wrote reports without doing experiments also. Yeah, and so I would be in the
Tell me
minority.
that we know our undergraduates too.
Yeah. So you know that, right? But then I used to be that person who actually would get a report and an error bar,
Yeah,
which
yeah.
would be believable and all. So yeah. But then when I went to Cambridge, that is, I mean, so you bring about a very interesting one thing you missed, particle physics, actually.
Oh, yeah. Okay. Thanks for mentioning that
No,
too.
just
Yeah,
because
yeah,
you've been very thorough, I just want to ensure that you're
yeah.
100
Yeah.
on 100. And so what happened is I joined the Part 2 physics course, right? And so Part 2
Hmm.
physics is, of course, a fascinating course, not only because of the subjects that are taught, but also because they have this, experimental component, which is very
Hmm.
different from how we do this in India. So they sort of give you a list of, let's say, certain experiments that are available for you to do. And then they say that, you have to choose something. And
Hmm.
then they tell you that, okay, so the things that you will need, they are here. You have 2 weeks. So you have to do the experiment and then come up with what you find.
Hmm.
So that's it. So there is nobody in the lab to actually sort of, how do we do things here? We have a lab, so people come into the lab, they are in their own stations doing their thing, and
Yeah,
we are
yeah.
moving around. It's not like that. So you have 2 weeks with that apparatus. Maybe there is somebody you can approach who's in some other, location.
Hmm. Hmm.
If you have some problem with something, you can go. But then the apparatus and you are left alone. Okay.
Absolutely correct.
Okay,
Yeah.
so now, of course, this is a new thing for me because
Hmm.
we didn't have this. It's very different. We wrote, as I said, we wrote reports before the experiment. I didn't, but so then I was left with this. So I said, now I chose two experiments. One of them was measuring E by H
Hmm.
using the Josephson effect.
Yeah, effect. Yeah, yeah.
So you know that you can, there's a Shapiro steps. So it's
Hmm.
proportional to E by H. So if you do with omega is 2 EV by H. And so
Hmm.
if you measure that and do the steps experiment, then you will be able to get the ratio of this constants, fundamental constants. So that I thought was a very nice thing. So somehow I felt that I wanted to do that. And the other experiment I chose is particle tracks.
Hmm.
So, they measure these particle tracks in these accelerators and so on. And so they have all this data. So you can analyze that and come up with, which particle led to this track and so on. And so these experiments were both 2 weeks interval. I mean, not 2 weeks
Hmm.
interval, 2 weeks duration.
Hmm.
And the first experiment was supposed to have an error of around 1 part in 10 to the 16 or 17. So it was a very precise experiment, and it was a more condensed matter one, right? Because I actually got a niobium given to me. I had to make a tip, I had to
Hmm.
sharpen it and make a Josephson junction and take it from there to getting the Shapiro steps and doing the E by H. For the particle tracks which followed that, it was fine to have an error of 60 to 70%.
Hmm.
Because,
Hmm.
particle physics experts, so they're complete
Yeah.
opposite of each
Opposite.
other, right? And in the same term, I had this exposure to two very different kinds of experiments, which taught me that experiments is something you should not fudge.
Hmm.
Because we tend to say, okay, so this is the expected answer, so can I get something around it? It doesn't work because 60 to 7. When I first got that 60 to 70% error, I was really worried. Oh
Hmm.
my God, I'm doing something terribly wrong because I didn't know at that time. And then when I went and reported this, they said that this is the expectation. And then that 1 in 10 to the 17. And Anindra has a role there also. So, he came and kept his laptop bag on the table next to the thing, and my steps disappeared.
Oh man.
So we've had funny Pauli effect from Anindra in many experiments throughout my life.
Oh man. No, no. I don't think that would be fair on him.
No, I think he will agree. So there are other anecdotes also, but then
Okay.
when he did experiments, he did a very good job,
Okay.
except that he
Okay.
didn't choose to continue with
Choose.
that.
Yeah.
So this is condensed matter and particle physics. But then I sort of realized in that part two, experimental exposure that what I really liked was the precision experiments.
Mm.
Because I sort of liked the fact that I could go down to that level. Somehow that fascinated me. So when I went to part 3 in physics, then I was supposed to take a project, which was a semester-long project kind of thing. So there I chose actually a sensing experiment, which was to do with squids, superconducting quantum interference devices. And so by using that, you can actually do what is called a gradiometer. So now we talk about this magnetometers and these quantum enhanced magnetometry, and all in the, a lot of buzzwords are happening. So this was decades ago, right? So we used to actually measure the Earth's magnetic field in 2 locations and cancel it off, and then see what the actual signal was. And so that was a beautiful experiment. And so that is little by little, this condensed matter thing started happening, nice, with focus on superconductivity, actually. So that was my part 3 experiment, which worked very well. And then, I mean, should I go to PhD now, or you have?
Yeah. Please tell us that particular part of it. Yeah.
Yeah. So of course, the part 3 experiment project, I did it with Dr. Ed Tart, who was in the device materials group in Cambridge, and also associated with Cavendish. And then there came the point that I wanted to continue for a PhD also in Cambridge. And I had like 3 options, which all of them were, happy to take me on as a student. One of them was Ed, who I did my part 3 project with. And also actually 4. So one was Mark Blameyer, who was the head of that department, who also worked with superconductivity, but then a little bit on these interfaces between ferromagnetics and superconductors, that kind of work. Then there was Gilbert Lonzerich, who you may know, who's like a very senior person.
Yes, I've heard about him.
Yeah, theoretical condensed matter.
Condensed matter, yeah.
Yeah, but then very hardcore theoretical condensed matter. And so that is where your research is very good, because I did have a lot of condensed matter upbringing, which and Gil Lonzerich and I had many discussions, and he felt that I would be a good fit for his group. And then there was Stephen Julian, who moved to Toronto later, who used to work with experiments in condensed matter. Okay. And so this was the choice. And then, it was a very interesting thing, because these people were not also similar in their seniority level. So Ed was actually a very young person, just, had started his group maybe a few years back. From then, Gil Lonzerich was already senior. Steve Julian was senior, and Mark Blameyer was the head of the department where Ed was. And so the decision on who I would like to join was also a little bit interesting, because for me, it was more about sort of allegiance to the person I already did something with, rather than go with somebody who may be actually a bigger name, so to speak. So I actually chose to continue working with Ed. Although, these were all much better known people, which was a very interesting choice, I would say, on hindsight, because nowadays people go with, a more established person, because then you feel that later on in your career that would be helpful and all that. But I just chose because I felt that, this is the person who gave me the opportunity to work with him on the project, so I should continue working with him. Okay. And so that is how I ended up working with Ed on, of course, it was again superconducting devices. So that was a theme, and experiments. And so, experiment anyway, I had an inclination, but Gil Lonzerich thing also happened. But then they were all very supportive of this choice as well. So that is very nice, actually, that, nobody really minds beyond a point. When you have these discussions and then you come up with a choice, people were supportive. And so that is how I ended up working with, superconducting devices, high TC superconducting devices with Ed. And then it so happened that Ed actually moved to Birmingham during the end of my second year of PhD. And I landed up working with Mark Blameyer for the rest of the PhD, which again is a coincidence. But then they were all, collaborating and all that, so not an issue. So that is how,
Very, very interesting. So during this particular period, you also did cryogenics, if I understand correctly. And that is something superconducting. Yeah. So you were transitioned to soft matter happened during this time, or were you also thinking?
No. So when I was doing my PhD, so Cambridge, of course, it's a 3-year PhD. I finished in 3.5. So at that time, it was basically 3 to 4 was the thing.
Yeah,
And
yeah,
I got
yeah.
a Gates Cambridge scholarship. That again was very important. But because, it's not cheap. England is not.
Absolutely, absolutely.
So I had the overseas research scholarship for the tuition part and the Gates Cambridge for the maintenance part of the problem. So I mean, I didn't have to, yeah. So that was also very useful. And then I worked on thin films, and so actually you may know the Cambridge Nanoscience Center,
Yes, yes.
which actually was not there when I started the PhD. So I worked for the first year in the clean room in the device materials group. And the Nanoscience Center came up, and I was one of the first PhD students to use all those brand new equipment in the Nanoscience Center. It was very nice. Everything worked. So clean room is something I really like, by the way,
Yeah.
which may not be so obvious from what I do now and so on and so forth. But I like going in with a substrate and then coming out with something which is so rich in physics.
Rich,
I
yeah.
really love clean room activities. And so, but then when I finished my PhD, again, there was so Anindo and I have always managed to sort of be at the same place at the same time. Even though we're not in the same, batch in some sense. Yeah, he was in DAMT, right? And so theoretical physics. So he was a junior research fellow. And so then we wanted to have to ensure that we could be there for one more year before we both moved wherever we might want to move next. And so then I wanted a shorter postdoctoral thing. And then because I was working all the time in Cavendish, I had many interactions with Uli Steiner, who was a soft condensed, who remains a soft condensed matter person. And it so happened that Uli is one of those people who is also not so regimented in his approach.
You can't box him to one thing. Yeah.
You can't. So then I worked on something called Josephson broadband spectroscopy. The short form is JOBS. So my job talk was always an anecdote you will find when we talk, right? So then it was on JOBS. And so what was interesting is that the kind of things I did, there was a direct, there was sort of overlap with what they were doing, although it was very different. So and at that time, the South African pulp and paper industry was visiting him. So they wanted, a postdoctoral person who would work on making whiter paper. And so Uli and I were discussing a few times, and then I sort of really liked that physics, So, having said that, it was in basically the next room. I was making the YBCO thin films in a room right next to the room where I was making these sol gel solutions. So I actually didn't feel a big shift there. It's basically a dimensional shift. So thin films to a little bottle. But I really enjoyed that white paper thing. And you will say, what is the big deal in a white piece of paper? Because it usually tends to be white. But the idea was that, titanium dioxide is used in this whiteness, right, as a pigment. But what the method that we devised was to use total internal reflection and have a thinner material. Equally white. And so I really enjoyed that. So I went to, Graz, to SAPI, South African pulp and paper industry, did the knowledge transfer and all. And so so I have never felt the need to always do like one thing and not be excited by something. Ultimately, it's all physics, right? And so that I think the soft condensed matter 1 year that I did was really something I enjoyed. Because, I realized that somewhere there are connects which I started making, which otherwise I would have lost out on had I just continued with just the one thing.
Yeah.
Mostly we get the opportunity. I just got an opportunity which, worked very well for me. Yeah.
Very, very interesting. Very interesting. Now I'll come to that transition, which I'm most interested in, about, because you moved to atomic molecular optical physics after that. Tell us about that transition, because that now defines your work.
And that has been the longest.
Yeah, longest. And also, some of the most interesting and important work also, which is, of course, there is a lot of things you have done. Among that, one of the very interesting aspect is that multi-slit experiment, Bond's rule, etc. I'm going to just come to that point. But first, please tell us about the transition.
Yeah. So then, I mean, of course, as you may note that, Josephson broadband spectroscopy, or for that matter, even squid gradiometry, these are all actually based on it's quantum mechanical.
Mm,
So
mm.
Josephson effect is a macroscopic quantum effect, right?
Quantum.
So there
Yes,
is a
yes.
quantum theme already in many things I have done,
Mm,
except let's say the soft condensed matter, which was not
mm.
so obviously
Yeah,
quantum, right?
yeah, yeah.
So when I was deciding on, the major postdoc, because this was a 1 year industry funded postdoc, right? I definitely wanted to stick to the quantum theme. So then what happened is that I visited John Martinez who was then in Santa Barbara.
Mhm.
And he had this fantastic effort on superconducting, quids, qubits already, right? I mean,
Mhm.
John
Mm,
Martinez.
mm.
So he went to Google and all that. So then I went and presented our work there and so on. So he wanted to uh, take me on as a postdoc
Mm.
to work on superconducting qubits.
Yeah, okay, okay.
Okay, and
Mm.
so that of course is a direct, it's a direct lift from the PhD. So I worked
PhD,
on
yeah.
superconducting devices. So it wasn't going to be a very big
Mm.
difference, except that we would do quantum computing, which again was an upcoming area at that time, not so popular and hot and all that, right? But then again, one of the things which Onindo and I, as I said, we have always tried to do is kind of remain in the same place to the extent possible. We seem to be tolerating each other, and so he got a very nice postdoctoral position in Perimeter Institute,
Perimeter,
which
yes.
was in Waterloo, which still remains in Waterloo in Canada. And so then, of course, Canada and Santa Barbara were not very close to each other.
Mm.
And so I didn't want to, again, I didn't want to commit to John Martinez specifically, because I wanted to see what opportunities would exist for me in Canada. And that is how I went to the summer school at IQC, Institute for Quantum
Mm.
Computing in Waterloo. And then I met Raymond Laflamme, who is the founding director of IQC.
I
And
guess,
so, of
okay.
course, I don't know whether you have met Raymond Laflamme, but
No.
I think if I were to choose a mentor for life, that would be him. And so when I met him, I said that, I have this experience in, devices and superconductivity, and I'm trying to see opportunities for postdoctoral positions for myself. And somewhat this geography is interesting to me for various reasons. And so IQC was upcoming at that time. And then, Ray introduced me to Gregor Weiss. You know him,
Yeah,
he's
yeah,
a
Gregor,
quantum.
yes.
And
Yeah,
so we
yes.
had lunch. And then he said that, Raphael Sorkin has been coming and discussing things with us. And there is this experiment we want to do to test Born rule, which is to do with triple slit architecture.
Mm-hmm.
Now, we
Mm-hmm.
don't know how to make these slits. Okay,
Mm.
because it's all theoretical. I mean, of course, Raphael Sorkin is one of the best known theorists, right? So,
Yeah, yeah.
but then we don't know how to, and so we don't have any experience of making anything at IQC yet, because they had nothing. There was no device at all. And so then they said that, if you were to consider coming to IQC as an IQC postdoctoral fellow, which
Mm.
was a prestigious position and all that, then we could start clean room activities at IQC through your coming in, and also pursue this experiment, which we have been now discussing without knowing what to do or how to do it. And so then I said, now this seems more again, Pawan, this is again one of those things, John Martinez, if somebody were to tell you today that, I did not work with John and went and joined a postdoc at IQC to start there to see how we could make devices for the whole institute. It seems a little foolhardy, because again, from a career point of view, that name is very important, John
Yeah, yeah,
Martinez
yeah.
superconducting. But then I feel that, of course, John again, I mean, this is what I've really realized, that people have not really necessarily, you talk to people, they realize that you make a choice based on various things.
Mm.
They don't mind as much as you would think. And so he was fine. And so I landed up at IQC as the only person with clean room experience. So then we started a little clean room in the first building. And, Jonathan Bow had also joined at that time as a faculty. So I was working with him. So I have also worked in indium arsenide nanowires and carbon nanotubes.
Wow.
Which again you missed from your homework. It's a little difficult. It's not so straightforward. So I actually have done a lot of device work at IQC while
Nice.
seeing their transition to 3 buildings, actually, finally now at QNC. and Vito, who became their clean room manager later, Vito and I, we helped, we were the first people to also have lay the seeds for the new clean room at Quantum Nano Center and all that. So I really, and I went to make devices at McMaster in University of London, Western Ontario, also in the engineering department in Waterloo. So I continued with my device thing while, starting with this slit experiment, right? So at that time, Gregor Weiss was, of course, still at IQC. And so there was a master student who was looking at the photons, but then they didn't know how to make the slits. So I went through different ways of making slits. So all of them were suboptimal. So what happened is, this is a little bit of a detail. So when you make slits, you need to ensure that the part between the slits is perfectly opaque.
Opaque, absolutely.
And so we had 5% transparency with aluminium, 3% transparency. So all these devices we were making were not perfect for the or experiment in mind because it was a precision experiment. Then we ended up making these stainless steel based ones. But then in the process of making these slits and so on, suddenly we realized that there was no one actually to do the experiment either because the master student had finished. And so then I said, then came this beautiful discussion that I had with Ray Laflamme and Gregor Weiss that why not increase the repertoire and work with photons?
Nice.
That is the introduction. So 2008, since 2008, I'm working with photons. And so, of course, I thankfully it was not, the physics is, again, there is a lot of connection. And of course, it didn't take me very long to pick up the architecture for making these photons. And then it so happened that Gregor moved back to Innsbruck. And not Innsbruck, then he's at Innsbruck now. And so Thomas Genevine came in and he inherited the lab and me and some other people and experiments with it. And so I remained in this transition. And then, of course, the experiment, I became, I actually did everything about the experiment after that.
Wonderful. This is probably not captured because, if somebody sees the science paper, which I'm going to link in the show notes anyway, the figure 1 of the science paper has this wonderful 100 micron and 30 micron slits. And there's a nice SCM picture because I'm saying this all because I have it in my screen right now. And I can now see where that came from. That's wonderful.
That history is not well known.
Well known, exactly.
And these slits, so if you want an anecdote with these slits, so the first set of slits we finally ordered, which was stainless steel, they got lost on campus. So the person who was named there, there was another person in the nutrition department who had the same name who received those slits, and he got fired from the university. So he took the slits. So then we had to order a new set of slits. But then, and that gave rise to that paper.
Yeah, it's a wonderful read. In fact, there's something very, very important and deep in that. I would urge listeners and also the people who are watching this particular episode to have a look at it. There's also that nice categorization: A, BC, AC, AB, and ABC thing. It's wonderful. See, one of the important consequences of this particular experiment is to take a notion and prove that first of all Bond's rule holds good, and second aspect is the linearity of quantum mechanics. Because that takes the realm of quantum mechanics from laboratory to the abstract world and tells you that how you should formulate the theory in a slightly more elaborate way, and also you should be cautious of not, if at all you're now fiddling around with the theory, you'll have to preserve this linearity. How was the reaction? See, how when you people published this, what was the kind of reaction? Of course, I think you probably even heard from Bond's family regarding this. Please tell us that about.
The reaction was actually fantastic. The experiment took much longer than we thought it would take, right? But then, and I also had these interesting heart-to-heart conversations with Raymond Laflamme. My career is not going to take off because, I don't have a paper yet, and then he was like, this experiment don't worry about it. He had foresight, which I didn't at that time, right? And so I'm very grateful to him for that. But then when it did happen, it was a beautiful thing to happen. And so so we actually had reactions from, of course, Gustav Born, who passed away a few years back, but then who wrote to us from Oxford. So Max Born's son. He was 93, I think, when he wrote that.
Wow.
Letter.
Okay.
And we have a postcard from him.
Yes. I've seen that. I've seen that. That's wonderful.
So I know, and a beautiful letter we got. I think that is the one I always look at when things don't go right, even now.
Very nice. Fantastic.
And then also Olivia Newton-John wrote to us because she is Max Born's sister's daughter. She also passed away recently, but then, the Grease star, right? So the famous John Travolta and, the Grease movie. So we had very interesting reactions from different communities. But most importantly, we had actually young students in Waterloo who actually, were very, so we did IQC's first YouTube video is on this experiment. And so I was the first.
I think, I probably have seen it also being posted in
but then it was funny because, IQC now has so much work that has happened in 15 years, right? But that was the first ever YouTube video that we did from IQC.
Nice.
And we had the science outreach program for young kids, which we do every year at IQC. And so I was telling them about some experiments or whatever. And then a little boy who was 8 came and told, "Aren't you the YouTube lady?" And I was like, this may be a good thing. It's an 8-year-old little person who I don't know. So I think the reaction to that experiment has overall been fascinating, both from scientists and non-scientists.
Wonderful. That also, resonates because you have actually intellectually taken that part of the idea and also, worked on it in a very different way, including some recent questions, what you've been asking and other things. I'm going to come to that part of that thing. Before that, please tell us about how did this trajectory further proceed? What was the timeline? And were you already thinking about coming back to India? And what was going on in your mind?
Yeah, so the experiment was published on 23rd of July 2010. It remains a date which I will remember, for obvious reasons. But then it so happened that we both, in this case, speaking on behalf of both Anindya and me, we both have been very family-oriented people, right? And so it was all, and also somehow we felt, and in my case specifically, I would say when we came back, experiments in quantum were not particularly very, very popular. So only NMR, I think, was really out there in India, right? And so I have always felt that, whatever.
Maybe a little bit of maybe Vasant had efforts.
Vasant, but his was cold. What I'm saying is that photons and using photons, that wasn't particularly available.
The single photon experiments, those kind of things were not
there. And Vasant has, of course, done. Unfortunately, Vasant. No more, but then I met him also when we first came to IISc, and at that time he was all right. So cold stuff has been happening for a while, but then you may recall that the cold atoms, they're also a bit cold, but then the cold atoms community, I'm surrounded by them at Hara, right? The trajectory, their physics problems were not necessarily quantum information based.
Yeah, you're right.
They had
atomic physics viewpoint.
Viewpoint, yeah.
Absolutely.
Quantum information or quantum computing, communication, these were not much discussed at that time. These were newer ideas which were coming in. And so, and of course, IQC was already becoming what it is now, right? In that phase already, it's a great place to be. And so I always felt that, if a little bit that I have learned, it'll be useful if one could do something to have an effort there, effort in India itself, right? Because after all, we are all Indians, and somehow we have this thing that we want to do something here. And so both of us had that very strong notion about, coming back as faculty members in India. Also, we wanted to be with our parents who were also, nobody's going any younger. But then, of course, unfortunately, Anindya's dad passed away in March in 2010. So we did not really manage to, be with him after coming back. But then that was always on our, so yeah, thinking about coming back is not a particularly new thing. We always meant to do that.
Okay. So now coming to the kind of present situation, now that you have established your lab, 2012 is
2012,
when
yeah, yeah,
2012 you moved back to India.
yeah, yeah.
How has been your experience, Urbasi? Because you have worked in top-notch places, institutions, including Cambridge and also QIC and other places. Uh, you probably would also have faced hardships, because setting up a laboratory in India is not a straightforward
You
thing.
know that, right?
Yeah,
Yeah.
yeah, of course, of course. I just want to know a little bit more about that effort, because you managed to also build something very interesting, and you also established some very good collaborations with places like ISRO and other
Correct.
institutions also.
Yeah, yeah.
I want to know what were the efforts you took, because this is important for any, let's say, formative years of any person who is coming back to India or starting their group in India. There will be
Yeah.
some lessons from what you would have
Absolutely,
to
yeah.
tell us. Yeah.
So here, of course, one needs to be as honest as possible about this. Not that I've been dishonest in any of the answers, but here,
Yeah.
being honest means that, some of it may not be always pleasant, right? So,
Mm,
we have our pros and cons, I would say.
mm,
So I would talk about it from a specifically institutional perspective, because RRI is a very special place
mm,
in many ways. So, it's not a very big place. So it prides itself in being in some kind of a niche place where only certain things are done, and the idea is that these things are done well in most cases, right? And so this is how RRI has always been. And so I think the fact that I ended up joining RRI is a lot to do with actually N. Kumar, who was alive at that time.
Yeah, yeah.
Because he was not the director. Ravi Subramaniam was the director. But then the discussions that I had before the actual decision were more with N. Kumar, because he had more overlap with what I envisioned and so on. Ravi was more into radio astronomy, right? So he was
Yes,
very
yes, you're
supportive,
right.
but in his own way. And so N. Kumar and Joseph Samuel, who you of course
Yeah,
know,
yeah, yes,
these were the
yes.
people I interacted with most actually before deciding that this would be the place. And so this place actually, the positives of RRI actually definitely were very instrumental in me setting up as quickly as I could. So, I mean, I have a little bit of a record that I came in March 2012, and then at that time I was shown a place which was a go down, where there was a lot of old telescope parts and data with an old telescope on top. And so the idea was to change that into a clean room.
Clean room. Okay. Oh
Yes.
man.
And so Ravi actually did a very interesting thing there. He sort of he wanted to do this for some time, like, change that place, but he just took me, I was the guinea pig, right? So I had come along. And so it was a perfect opportunity for him to change that thing, and which I took up. And so what I really firmly believe is very helpful. I don't know whether this is something you share, your thoughts may be different, but setting up a lab is not just about the instruments. It's
Absolutely.
also
Absolutely.
about
Yeah.
the infrastructure that you're setting up. That can be a long process. And it was a go down to a clean room. So it was an even longer process, could have been. But then I firmly believe that my expertise is in physics and associated areas. I'm not a civil engineer, neither am I an electrician. So we have all these departments here. So one thing I did, which I feel worked for me, is that I had one or two meetings with all of them, and then I said that this is what I need, but they should take the lead in setting up those facilities. I don't want to micromanage them. And I think that they really appreciated, at least the group that was here. And so they actually collaborated with each other. Otherwise, these departments don't always talk to each other.
Talk to each other.
Yeah. And so this, I think, was one of the things I felt worked in my favor in setting up the infrastructure part. Otherwise, we would be stuck with that situation. And then, of course, I had a deadline, which I had internal deadline I had set. December 2012, I don't know whether you recall, we had this very nice conference at IISc on quantum. That was one of the first
Yes, my
quantum
first
conferences.
one. Yeah, yeah.
First one. And so I was in the
Apurva
organizing
Patel
committee.
and
Apurva, Apurva was the main, he was the main organizer, and I was also in the organizing committee. I had just joined, and they wanted me to be a part of it and all that. And we also had a very nice school at ICTS, which I had mainly organized.
Mainly organized, yeah.
Yeah. And so that was December 2012. So that was fixed. And so then I said that, I'm inviting all these people. And many of them came to India for the first time. for this
Ah.
event, right? And so, including Ray Laflamme,
Mm.
Gregor Weiss, and
Mm.
Thomas Genevieve, and also Gilles Brassard, who's the BB-84's B, one of the Bs,
Mm.
right?
Mm.
And so then I said, if these people are coming, they need to inaugurate my lab. And
Nice,
so
nice.
I actually, impressed upon whoever was involved in getting this lab thing done, including myself, that we have a December deadline.
Mm.
And it is because of this reason. So somehow that romanticism associated with this lab being inaugurated by this bunch of dignitaries also worked for the non-academic people.
People. Okay, nice.
And
Nice.
so somehow that all worked out, and then we also had the Kaiser Fire in before that, and
Mm.
we started same year.
Nice, nice, excellent, excellent. I should also mention, my formative years as an undergraduate, I spent a lot of time at RRI. In
Okay,
fact,
yeah,
G. Srinivasan and GS Ranganath, these are the two people whom I consider as kind of my gurus. I have
right.
had a great kind of, it's part of my education. I can't, and the library also is
Oh, the
something I
library is
really,
fantastic still.
is fantastic.
Yeah, yeah.
So, another aspect I want to ask, Urbasi, you have been also a very strong proponent of doing science in a way that also is communicated very effectively to the public. You not only just
I
are
tried.
but yeah,
Yeah.
it's a very important thing. In fact, I think it's something which is an imperative now for anybody who does science, more so people who do experimental science, because the Indian kind of physics community has been excellent in theoretical physics for a very long time. There have
Absolutely.
been a few, and there have
Very
been
good
few
experimentalists as well. Yeah,
experimentalists also, but the proportionality is not there, in the sense
true.
there is disproportionately outstanding theoretical physicists and few experimentalists, and you are one of them, and
Thank
who
you.
is also trying to actually push this envelope going forward.
Mm.
You have been also communicating with public, talking about science, giving lectures which are slightly more broader in the context. And Bangalore is also a great place. You have
Yeah,
also given that nice copy with
yeah.
curiosity,
Curiosity.
a
Yeah.
wonderful initiative. Vijay Krishnamurthy and ICTS actually
Mm.
have been organizing. Tell us about that component, because I see not just now, for a very long time you have been
Mm.
actually actively engaging and putting your thoughts in the public domain, and in
Yeah.
a very effective way. That is important too. Please tell
Yeah.
us, because there is again a lesson
Mm.
for all of us,
Mm.
including people who have been established in the research community. They need to also probably reach out to the public. Please
I
tell
would
us.
I would say there are two components to this, Pavan, if I were
Mm.
to just make it
Mm.
sort of quantitative. One of them is I truly felt that there was a need to do this for the particular field that I work in. Because when I came in 2011, 2012, at that time, it wasn't that popular
Mm.
in
Mm.
India yet, although it had started picking up, globally. We were still not that convinced about the repercussions of quantum computing, quantum
Mm.
communications, and so on. In fact, one of my colleagues here at RRI, who I will not name, but then when I met this person after joining, this person said, I love the work that you're doing, but I don't really believe in quantum computing. It's never going to happen. Okay, so this is the kind of reaction I've had from
Mm.
colleagues, and the same colleague now is actually building stuff towards a quantum computer. So I would say that if this has been a journey, and so I felt very early on, even in the first year when I was here already, that if I were to enable a little change in mindset from my own small
Yeah.
abilities, I should do that. And so I started getting engaged in popular
Mm.
discussions on science in whatever fora felt the need to invite me, and so on and so forth. So I've always taken that up, because first of all I feel that it is important for every kind of person to know about
Mm.
this field. Secondly, also the students, because students also in India, I think the best students feel that theory is the way to go
Mm.
a
Mm.
little
You're
bit.
right.
They sort of feel that intellectually it is theoretical
Mm.
physics, or if they want to do physics, is what they should be doing. And I wanted to bring about a little change in that mindset also, because I do believe that what we do is intellectually very stimulating.
Yeah.
And experimentalists also do a lot of theory.
Absolutely correct.
So this is sometimes not understood by
Mm.
the young kids, right? So this was also on my agenda, that I have actually done a lot of public outreach in different parts of India, not just in Bangalore, specifically also with a mindset to educate people on possibilities beyond theoretical physics. Because you have very rightly said that we have a disproportionate number there, and it's not bad in any way, but I think we need to increase this number.
Exactly. We have to bring the experiments up to the upper level.
So this was one of the reasons why I felt that it is important. Secondly, also RRI has traditionally not been the kind of place which has been very interested in talking about its work. And this is something I felt. So in 2014, we had this very nice, I would say, paper published on this non-classical paths and interference experiments, which was published in PRL and so on. And so Telegraph contacted me, and because I was the corresponding author, and they wanted some thing. And so I said what I needed to say about the experiment, and they published a nice article on it. But then, colleagues here, they did not like that at that time. And so they sort of said that, RRI is Raman Research Institute, our middle name is research. So we don't have to talk about it. We will just continue doing it and people will anyway know. And I felt a little odd because I was just 2 years into RRI. And I didn't do it on my own. Like if somebody contacts you, it would be very strange for me to say, no, I cannot tell you about our work because we are RRI. And so it was not pleasant. But then I continued with my efforts, and I now am very proud. Say, even if it's a very small role, we now have a outreach cell.
Yes.
Since 2019, and there is a lot of work being done, which is getting written up and all that.
Yes. Yeah, Anjali Marar was doing fantastic work.
She's fantastic. And we have new people who have also joined who are fantastic as well. And so I would say, I'm not saying that, but what I say is that, I have this little laugh thinking about the mindset change that has happened. And I feel that I think we have to go with the times. And the second thing, Pawan, is that, all said and done, maybe, your and my research has a little more practical element, which is easier to explain why it is useful to society.
You're right.
But then some of it may not be that easy also. So I do believe that it is our responsibility because ultimately we are using the taxpayers' resources to do whatever we are doing and also sustaining ourselves. So why not talk a little bit about it in a way that will be intelligible to people beyond our community? Because then at least there is some way people know that, okay, this person deserves to do what she or he is doing. So these were the two reasons why I like taking up such activities.
You know what? I should mention the connection to RRI. My connection to RRI was because of the outreach what Professor G. Srinivasan.
Oh, he was,
astrophysics. I'm actually a lifelong student of astrophysics. Although I do love optics, science of matter.
But astrophysics is optics, Pawan.
Yeah, it is.
Large-scale optics.
Large-scale optics.
Yeah. So we have our new tagline, from quantum to cosmos.
Cosmos. Nice. Outstanding. So tell us a little bit about your collaboration with ISRO, and then we'll also go forward and kind of wind up here.
Sure. Yeah. So ISRO, the ISRO thing is of course a very interesting collaboration. So when I first joined, and 2012, in 2013 itself, I sort of started motivating satellite QKD. Because this is something which was being taken up at IQC as well, and I felt that if we could start something towards that, then we would have an opportunity to make larger contributions as a country and so on. But then the agencies I was speaking to at that time, they were not really very privy to the usefulness of such a topic, I would say. Questions were like, is this really science or science fiction? A photon is going to go all the way to a satellite. Will it survive? I have had wonderful discussions. And I said, we need to detect these photons. And I have had questions like, why do you need a detector? Why not just catch them as they come along? So beautiful discussions. And so very frustrating ones as well. and then a neighboring country launched a mission and launched a satellite in 2016. And then, of course, I was already in discussion with ISRO by then. It was not the first agency I was in discussion with, but that was the time frame when I was discussing with them, which was much motivated because, there are, of course, important people at RRI who have had ISRO connection. In the governing council, for instance. So who were very, I would say, I'm very lucky that they're very supportive of what we do. And so they said that, I think we should talk to ISRO instead of trying to get this done some other way and so on. And then the launch happened. And so I would say ISRO has been one of those agencies which trusted what we were doing much before it became a hype. And our project started in 2017. So this is India's first project on satellite QPD. And I would say that, the fact that ISRO, whoever was representing ISRO at the time, the group of people believed in our vision. And that is how this collaboration started. And so we have done, of course, many things as we have proceeded over the last several years in ground-based milestones.
Yes.
So nice. All the milestones with free space and moving receiver and all these things we have achieved. Now, we want to take it to the space level. And now ISRO, of course, over the last few years has also started its own program on, space-based quantum. And so I think, so while we have, of course, been working as well. So I think all of this comes together now beautifully in an umbrella.
Wonderful. Wonderful. So one more aspect which is also equally important is something related to gender equity. And, I have really, been very impressed and also inspired on some of the things what you have raised in some of the panel discussions. I have been actually in the audience of many of those discussions. And I felt you really put across some very important points. And there is a very, strong necessity for us to actually think about this. Given that, you are physicist, you're an experimental physicist, and in addition to that, you actually are a woman physicist. Okay, these are all, of course, all these things overlap, and very, very nicely they actually overlap. But there is still a lack of culture of injecting more women into physics, especially including experimental physics, because I myself know that number is not a large number. True. And you have actually thought through this and also been very vocal about these particular things. Could you please share your thoughts in a couple of minutes about this issue, Urbasi? Because this is very important.
This is of course, this is an issue which so first of all, the fact that you realize that there is an issue is nice. Because, in many of these discussions that I have been a part of, I have felt that most of the time people feel that, this is not an issue anymore, because there are some steps which have been taken towards, some schemes and mechanisms which have come up. And so people feel that that is enough, and so we have already done what we need to do and this will happen. So there is nothing else to discuss. And that is actually the first problem, I feel, because it's not true. So it's not, we have a leaky pipeline. So we lose women as we go higher and higher in terms of education. So school, you don't see any difference. But then as you go to college, also it's fine. Masters, it's okay. PhD, suddenly you see the number of enrollments. You always see a bias.
Absolutely.
Especially in physics. And biology may be slightly different, but in physics. And then, of course, permanent positions and faculty, then, of course, you see the real difference. So I do believe that, this is the first thing to realize that this still needs to be solved is important. But I have my own thoughts, which are sometimes not always matching with my other female colleagues. So for instance, we have this prize, Young Scientist Prize. Okay. And so, there was a Young Scientist Prize that was announced sometime. And so I was part of the judging panel or whatever. And so then I was told that, it's always been men who have received that prize. And it's not an Indian thing. I'm now talking about a global Young Scientist Prize. I'm not naming the prize. And so it has always been men. And so then I'm in the panel. So I say, then the question comes, do you want to institute a Young Woman Scientist Prize as well in this topic? And then, of course, my answer to that is no. Because you see, then what happens is that the Young Scientist Prize becomes specifically not for the woman.
For women, yeah.
So as a woman, you only get the Young Woman Scientist Prize, but you are not considered because there's already a category for you. So I would say that in order to bring about a change, what we could do is perhaps increase the number a little. Instead of giving one, even if we make it two, then over the years, the number of women will increase, because maybe sometimes women are losing out just because they're not coming out as the number one choice, for whatever reason. And so this is the kind of change I think we need. Because, as a woman scientist, I don't think I need to be told that I am being given something because I'm a woman.
Absolutely correct.
I want to be given
Absolutely.
something in spite of being a woman.
Yes,
You know?
it doesn't matter. In fact, there, I totally agree with you. I totally agree with you.
And
It's
so
an
some of
important
the
point.
things which I think, the gender balance in science is very important because men and women don't always think alike.
Mm.
And so I think that diversity of thought also affects our science. And so I think I actually do believe that, and I'm not saying one is superior to the other or whatever, but it's just that diversity is necessary even for growth of science.
Absolutely.
And so this thought that, everything is already resolved is a first problem, I feel.
No. So very well put. So very well put. In fact, people who are listening to this and also, seeing this interaction conversation, they may actually want to pick up few points and look at it in greater detail in case of some policy people actually are looking at it.
That will be
I hope
nice. Yes.
that'll be nice. It'll be good to have some kind of positive change. There are already things happening,
Yeah.
but there is much more to happen in
No,
this
you don't
direction.
want to be the token woman in a panel.
Yeah, yeah. I agree.
There are a few such, I
Mm,
mean, I'm slowly getting to be one of them.
mm,
But then, it is just that I think, it should be natural to have diversity. So
absolutely.
EDI is not about enforcement.
Mm,
It
mm.
should be systemic.
Systemic,
And
systemic.
it's not
It
just
should be
about
bottom
women.
up. It should be bottom up. Yeah,
It's not just women. There are other, disadvantaged, I would say, sections of society, and we are not
absolutely,
that. So
absolutely.
we need to be a little more cognizant of
Yes,
this fact. Then I think it'll happen. Otherwise, it is a little bit superficial.
superficial. Absolutely, absolutely. Great. There are so many interesting things. I'm very sure this will not be the only time we'll have the conversation on Pratiswari Urbasi. I would be very happy to actually invite you again, and
Thanks for tolerating me and now promising to tolerate me again.
No, no, no. It will be
Yeah.
an absolute pleasure and honor. Uh, Before we just leave, tell us a little bit about your future plans. What is the kind of directions you would want to take your work, and also
Yeah.
other things what you want to pursue. Yeah.
So, of course, one of the things which we have been doing, which we have definitely been. So, you put that very well when we began the interview. So, while, of course, there is a technology focus, and I am an important part of the National Quantum Mission, and I've been doing this for a while, helping it take shape and also now participating in it, right? So, that quantum communications will definitely be one of our
Yeah.
key areas. But one of the things which I will definitely continue doing is fundamental tests of quantum
Nice.
mechanics and quantum optics and
Fantastic.
quantum information itself, because that is something I really feel very, I feel very happy doing.
Happy.
Happiness is important, but I also feel that the happiness does reflect in making small contributions towards a little bit better understanding of small aspects that we have been
Absolutely.
contributing to. So I will continue with this marriage of fundamental science and applied technology. Although there is a lot of pressure to do product-oriented work,
Yeah.
but then I definitely will not do just that. Although I'm happy to say that I have now co-founded a startup.
Wow, wonderful. Please tell us about a little bit
Maybe
about that.
something you again didn't know in your little.
Yeah. I did not know this. I did not know
Very
this.
thorough homework.
Yeah.
So we have a new startup, QSync Technologies. Quantum Synergy, we call ourselves. So again, the name embodies what we want to do. We want to take things which are, getting mature in the lab to a product level. And so the lab level can only reach a certain technology readiness level, and that is something we cannot change, right? But then some of it may be amenable towards a product as well. And so we have now realized, I mean, of course, I have been much motivated by various people and agencies to do something of this kind for a long time now, because people do believe that what we do has the potential to make a product as well. But then I have taken this decision and we have registered it only this year, because I don't like to just talk about something and not have anything else other than a website. So now we actually have things which are going to, become product ready this year.
Nice.
And so
Nice.
I'm happy that, I'm being able to see this transition, although we'll have dedicated people who will be obviously better to make it, at that high level of TRL. I will remain an advisor to my startup. Yeah.
Wonderful, wonderful. I wish you all the best for all the
Thank you.
ventures, what you're now taking up, and also which has already been going on. And
Yeah.
as I mentioned, we'll definitely have you again
Oh,
on
but
the
one more
next
thing,
episode.
Pawan, I
Yeah.
think before we wind up, I think one more thing that needs to be discussed is that I also have the Canada Experience Research Chair.
Yes,
And
yes. Sorry,
yeah,
I have to explicitly mention Urbasi is also, part of
I,
the Canadian academic system in a
I didn't
way.
want you to make an announcement of it or whatever, but
No,
it's
no,
just
no.
that that
Yeah.
is another position that I
Person
have, and
had,
of
yeah.
course, and one of the things which we are still trying to figure out, not me,
Hmm,
beyond my pay scale,
hmm.
but whoever it is who is our trying to figure out is how to make it happen so that both
Happen,
of
yeah.
these things can happen in parallel. And of course, I'm just continuing with the science that is needed,
Hmm, hmm.
irrespective of geography. But I'm
Nice.
sincerely hopeful that if at all some policymaker is listening to our
Hmm.
conversation, they should realize that science is global.
Absolutely,
And a
absolutely.
position like this gives us an opportunity to really be international, which otherwise is just a phrase we sometimes tend to use.
Absolutely, absolutely. In fact,
So,
this is also a golden opportunity to set forth a policy where
yes,
this can become an important benchmark to go forward and do it.
to have
It's
such
also
an
not an
event,
easy
and
thing to come, right? It's not an
no,
easy thing to come. That's the thing. Yeah.
it was, of course, a huge privilege and
Hmm.
honor to be given this position. But then I
Yeah.
do hope that, this sort of thing, because it happens in other countries, and I'm
Yeah.
quite sure
Yeah.
with all
Yeah.
our, very modern policies right now, something will emerge.
Will emerge. Yeah. Yeah, great. See, I again, congratulate on all these things, what you've done, and also,
Thank you very much.
best wishes for all the ventures you want to take up. And as I told, Pratidwani will surely come back to you, and we'll have more of your Dwani later on at some point of
And,
time.
and I also want to congratulate you on actually probably having one of the best science podcasts that exists
Thank
currently globally. Because this whole idea of humanizing science
Thanks. Yeah.
is very nice, and I think you're the perfect person to be doing it, right?
Thank you.
So
Thank you very much.
congratulations. Yeah.
Yeah. So this is Pratidwani, where we try to humanize science. This time with the one and the only Urbashi Sinha.
Oh,
Correct?
wonderful. Yes. Thank
Okay.
you.
Thanks.